Yeah. And you know, my video that I made is probably better than this, but this has in it you asking questions and you giving visual cues so that I can say, oh, they get it or they don't get it. So how are we doing? Boring as heck? Let's move on, or we're overwhelmed?
Good.
Good.
We're good, okay.
Sorry that
Okay, so now you have, you're always going to still assume variables are positive real numbers, because if you had a negative under a radical, you would have a problem. So you're going to deal with this next week. It's in the video. Here, I'm not going to do this one. I want you to just kind of take a peek at it and say, what would I do with this? Probably you would use the quotient rule here first and say, hey, I'm going to split this into the square root of 2x over a square root of 16. And then that square root of 16 turns into a 4, right?
Mm-hmm.
And then you would say, now I'm going to create a common denominator, which in this case would be 8, you see? So you have to do a couple things. Do I need to do it real fast, or give me a nod if you want to do it, and give me a shake of your head if you don't want to do it?
Nah.
Doesn't look super thrilling. Jordan? Nah. Okay. If you're ever shy in here, you can always email me.
Maya's here.
Do it.
Maya is here. She said she was late from
Okay.
work.
Oh, hello. Yes, but you're here. That's good. So let's do.
Yeah, I was just late. Got here late. I just got from work.
Okay. That's fine. Thank you for coming. Okay. Where is my mouse? Because then I'm drawing. There. Number 5 should be super boring, because you should say, hey, I have 3 apples and 6 apples is 9 apples. And then this is a negative $1 plus $9. Do you see what I'm saying? So it's just plus $8. And then you might want to, you could have originally simplified each term and then put them together. But I chose to go ahead and combine these two, and now I'm going to still simplify. Yes? So I see a lot of frozen screens, so I don't know if that's me or not. It does not tell me today that my internet connection is unstable. So square root of y to the 6, we would simplify that by saying I need something squared. What has to be in here?
Y to the 3rd.
Right? And then that whole thing comes out. This piece matches, or that exponent matches the index. So this whole piece comes out, and your final answer is now 9 plus 8y cubed, or 8y cubed plus 9. Order doesn't matter. We usually like to lead with the higher exponent. I don't think it'll matter in my math lab at this point. All is well?
Give me a second to write it down. It restarted on me.
Okay. But this was a really basic one. We're okay?
Yeah.
Why didn't we combine why didn't we add 8 and 9?
Oh, because I can't hit the back button. Hang on, because they're not like terms. This is the 9 minus plus 8.
Oh, okay. Never mind. I see it now.
You see it? Okay.
Yeah.
Because this would be 9 plus 8y cubed. Whoops, 8. And this is $9 and 8 tomatoes.
Okay.
Yeah? Okay. That's good to ask people. It doesn't ever matter in here. Remember, this is just like in class where you're doing somebody else a favor when you're asking because they're too shy to ask. We did number 7 the other day. What's different about number 7, what I like about it is also has variables to deal with. Number 6, you can technically plug that whole thing in a calculator, and if you have a good calculator, it will shoot out what you need. I like to show the work, but let me see if there's another one with a, nope. Okay, now and then we're going to multiply. So let's do this one here. If you can help me. So this is one of those where you're going to have to make a tree, you know, and I don't have, my basic math is not, I'm not on top of my game. I've been up since 4, that's no excuse, but 4 a.m., not 4 p.m. 175, I know it's divisible by 5, and then I hope you'll help me. Or, hey, oh, it's, wait, 7 quarters, right? Because 8 quarters is $2. Can we do it that way? Is that right? Catch me if I'm
Yes.
wrong. I'm telling you, this is on you guys.
Yeah, no,
Okay.
yeah.
Or just leave me hanging,
25.
like in class, you always leave me hanging.
Do not.
Like let her suffer at
No,
the
it
board.
It is 25 and 7.
Thank you. So -3. 8 is 2 cubed, so 2 squared times 2. Or you could have said 4 times 2 is 8, you know, -3. I don't know how this is going to turn out yet. It's just always interesting because I don't work these ahead of time, so I don't remember. 63 is 9 times 7, so 3 squared times 7. You see it?
Mm-hmm.
And that's all basic math. And then you pull the 5, and you could go ahead and do stuff. Then here you pull the 2, and the 2 stays under. And here you pull the 3, and the 7 stays under. And then again, catch me if I'm wrong, 9 times 5 is 45. So I'm really simplifying each one. Sorry? Some of you are taking every note. I understand, and I think it's wonderful. I just don't want you to get too hung up. Like I show every single little step, you know, don't feel that you have to do that, but everybody has a different pace, and I'm rushing because we have a lot to do, but at the same time, I don't expect you all to be at the same pace, okay? So don't feel rushed. You can always just write this down and then follow through with it after we get off here and say, oh, can I figure out how, oh, that, what happened here? Oh, 3 times 3 was 9, you know, that kind of thing. And then you say, do I have like terms? So this is where you have to say, they're all square roots, but that doesn't matter because when I'm adding and subtracting, I have to have the same thing under the root as well as the same index. So I can say I have $45 minus $9. So how many dollars do I have? $36. You see what I'm saying?
Mm-hmm.
And then I hope I didn't make a mistake here, but this is all that's going to happen. Nothing else is going to happen. Yes?
Mm-hmm.
And then I do want to work one that, Amanda, you don't mind me sharing. You're not shy. But I have that one that you had asked about. You know, if we can discuss it here for a minute, that would help. It was, I think it was in
Go
10.3.
ahead.
Okay, so I'm going
Like
to
I
bring
said,
up
if it
that one.
helps everybody else, I'm good with it.
It does, and I just, I'm gonna, I don't know how big this is gonna get. Okay, so that'll work. Let me clear all my drawings. Okay, so this was where I need to clarify something. This was 3 times the square root of 18. You had asked, you know, about that 16. If I have x to the 18th, okay, so if I have a variable with it, then I have to look at, hey, I need it evenly divisible by the index, which is a 2, and I need it close to 18. So actually, in this case, it would have been a, you see what I'm saying? Like it would have been, I need something squared, and what has to be in here, the 9. You see it? So that's when it's a variable, you look at evenly divisible by the index. Or if you have a square root of 27, let's say, oh, I shouldn't have said that. Hang on a minute. Not the square root of 27, but the square root of x to the 27th. You know, let's say it has an exponent. This is a variable with an exponent. You could split that and you would split it into something evenly divisible by 2. And then you would say, what's the leftover? You see, because those two items together have to get you back to the x to the 27th. Then you say, I have to create something squared, and this is that leftover x. And what does this have to be? 13 times 2, you see? This is where you, when you have a variable with it, you fiddle with the thing under the radical until stuff comes out, and your goal is always to create an exponent that matches your index. So then this whole piece will come out. I'll have to, this will come out. It's a mess. I shouldn't be recording this. What a mess. X to the 13th, and then what stays under, you see? But this has to do with the exponent matching the index, or evenly divisible by the index. When you have something like this, there is no variable. So it's simply, you simplify it by breaking the 18 into the old-fashioned 2 times 9 and 3 times 3. See what I'm saying? See it? So then you have the 3 comes out. So this 3 comes down, this 3 comes out, because that's where you want to put that in the parentheses. You know, some of you like that with the parentheses. And that 3 comes out, and then the other one stays under. And then the 3 times 3 is a 9. So this is this thing simplified. I hope that helps clarify a little bit. But just numbers is treated differently than the exponents with variables with exponents. Okay, so, and thank you for sending that. And I always ask you guys, please send me something. Oh, I can't get it. No, I can't close it. Arc. I might have to stop share for a second. Hang on a second. I got to get rid of this thing. No, it'll go back to sharing. All right. We worked that one, right? And I cleaned it up. Okay. Annotate. Sorry, I'm back. Whoops. We did number 7 the other day, so it has variables in it too, and you just ask what comes out, what stays under, and create like terms. Do you see how this is just fractions, but if you split them up with the quotient rule we did the other day, you just have a square root of 45 over square root of x squared, and then the x comes out, and on the other one, the denominator, the 3x comes out. Do we see it? I'm not gonna work this whole thing, but you know, you would say square root of 45, square root of x squared, square root of 5. Don't write this whole thing down because I'm not gonna work it all. And this is a 3 squared x squared, and then you would say, simplify each one first, you know, and square root of 45 you can simplify. And then this one is a 3x, and then you simplified that piece in the top, and then you turn around and you need to make a common denominator. And then you go across. Yes? So I'm going a little fast on this one, but it's no different from what we already did. It's just that you're dealing with splitting it up first, cleaning up the bottom. The perimeter, did we do this the other day?
Yes.
Perimeter? All we do is combine, you know, when you find the perimeter of this fence or whatever it is, you just add them all up. Forget about the inch. The inch is part of a final answer, and you just add them all together. Yes? So as you add them, you'll notice they're not the same, and then you simplify each piece and they turn into like terms. Question? Do I work it? Are we good? Moving on?
Good.
Okay. So if, you know, if you ever see one and you're like, man, I wish you'd work that, just send me a message and I'll work it for you. Okay, so. Did we work one like this? I don't know. This is where I always yell alert, alert. Back in chapter 5, you might have had this. And I told you that it's never x squared plus 9 and it's never x squared minus 9. Does that sound familiar? What did I say at the time? Do we remember, folks? I mean, some of you were with me at the time visually, like I could see your face. You don't just square each one, right? Like this is different than when you have a 3x quantity squared. Yes, that's a 3 squared x squared, which is a 9x squared. This is different. This is a binomial squared. So the only way you're going to get a true representation is to say that's it times itself, and that causes that thing when you're foiling. And this is still going to get you in trouble at the end of this one because I just did the videos for next week. And that's where people keep messing it up in the class and I keep yelling. But this is an x squared minus 3x minus another 3x. And then -3 times -3 is +9. Do we remember? Or this is the formula where you can use the formula a minus b quantity squared is a squared minus 2ab plus b squared. This is either formula or you can foil. You can always foil. So most of you do better with foiling. Some of you do fine with the formula, but you're going to get twice the middle term. You see, this is that piece here. So if you do this one here, A, you would want to, for safety reasons, you would want to write it out twice and then foil it. Are we clear though? If you like the formula, I'm all for it. I love the formula, but I can spend a lot of time spending on the formula when only 9 out of 10 people prefer the foil way. So I'm going to stick with foiling right now because of time management, you know. So can we foil this? Square root of 3 times square root of 3 is square root of 3 squared. Please don't make it a 9 because then you have to turn around and figure out what comes out. And this makes it easier. Square root of 3 times negative square root of 7, negative square root of 3 times 7 is 21. Nothing's going to happen because the numbers are too small. You know, they're all to the first power, 3 to the first, 7 to the first. Nothing's going to happen. Then you have a negative square root of 7 times the square root of 3, which is a negative square root of 21. How are we done? Yes? 2, 4, 6, 8, 10, and I see 13. Okay. And then I have the last, which is a negative times a negative is a positive, and a square root of 7 times a square root of 7. Yes, it's a square root of 49, but I'm just going to call it a 7 squared. And then the 3 comes out. And then I have minus 1 potato. Minus 1 potato is what? Well, I think dollars, because we can't really make potatoes disappear. I borrow $1. I borrow $1. I owe you nothing. Let's do business. Like some people cancel these, you know, I'm like, they don't cancel. I borrow $1, I borrow another $1. I owe you $2. Are we clear? If you don't see a coefficient, it's a 1. Yes? Oh, $1, oh, $1. Basic math matters. Okay, plus square root of 7, square root of 7. Then you combine like terms. 3 plus 7 is hopefully 10. You see how the math is very easy on these two. Like they use very small numbers. How are we doing? Most fun you've ever had on a Friday night? Oh wait, it's Thursday, we're good. Jordan, you look thrilled, super thrilled.
I am. I'm just so excited about it.
I know, right? Oh. So if I asked you to do B,
Like stop going away.
say that again? Oh, my internet was,
wish my screen would just like go away. Mine's going. I have no idea what you just did because it just like went away and wouldn't come back. And
yeah, I had a notice just now that said my internet connection was unstable for a minute. So everybody's watching Netflix or something. Not in my house because they're not allowed. But the neighbors, the neighbors are watching Netflix. In my house, I'm like, I'm on the internet. You're using regular old VHS tape. Deal with it. Okay, so which part? Was that Tiffany or was it Nicole? I couldn't tell. Nicole, was that you?
It was not Nicole.
Oh, it was not Nicole. Tiffany, was that you?
Nope, it was Amanda, I think.
Okay, so if you don't see what I did, I just want to say the one where you borrow $1 and borrow $1, that was okay. I'm trying to go back a little. So this requires patience on your part as well as mine. So if you, I don't know, if you didn't see what I did, I simplified each term, then I combined these two because they're like, and then this 3 and that 7 made a 10. Yes, maybe?
Mm-hmm.
Yes.
Did anybody want to try the next one? Why don't you guys try that one? I want to see what you're going to do with it. And this is where I'm going to test something. Jordan, we tried this the other day where we said, let's share the screen. Because I was complaining to the bosses. I'm not really complaining. I'm simply arguing the fact that doing this as a regular class full-time is not the best way. It's a wonderful tool to stay in touch. It's a wonderful tool to do some practicing. But as far as teaching this like that, so he says, well, people can show their screen, because in a classroom, I walk around and I check on you guys and I watch you work, and then I can stop you before you're at step 17 and you've messed it all up at step 2. That's my argument with them. Like, I try to catch you before you get frustrated. But then he says, well, you can just share the screen. Okay, with 25 students, so show me your screen. And then you need to have a tablet, and you need to write with this pen on this writing thing, like this is a tablet I use, so I can communicate. So, I'd love to see somebody's screen, but when you just write it on paper, it's hard for me to read it. But you can email me pictures and I can look at them while we're in class, because we have time for that. I'm gonna check on you. You guys are working this one, right? While I'm babbling up here.
Are we
That's how I do
working
it in
B?
class.
Is that what we're supposed to be doing?
B, yep. I want to make sure we all get the same thing and we're all going to yell the same answer at the same time. That's what we do in class. I'm just going to check my roles so you guys get credit. So if you have a black screen, once in a while, maybe chime in. I have Freedom down, and I have Tiffany and Randy. And Maya and Amanda. Pretty good attendance. I'm pretty happy with this. 14 people. It's pretty good. So I'm going to move you guys over and I'm going to work it, and let's see if we get the same thing. I don't need it so. My fan's on. How we doing so far? That happened? How we doing? Would we have gotten there? I'm not done yet, but
That's what I got.
very good.
Okay.
So, and then you say, I'm gonna take that X out. And then you say, I borrowed $10, I borrow another $10. They don't cancel magically. I owe 20, yes?
Right.
And then I have that plus 25 hanging there. And then am I done? And then sometimes you can combine more stuff and other times you can't. And in this case, then they're not like terms, right? So this is the
Done,
end,
right?
This is the end, right? And order doesn't matter as long as you keep the sign that goes with it. Yeah?
Okay.
My child. Okay, Daddy's home, thank goodness.
So the 4x minus 20,
The square root
the
of
final
X.
answer.
Yeah, the thing I circled is the final answer because none of them are like terms. You see,
Yeah.
if you think of like terms as it's still same variable, same exponent, square root of X is really X to the 1/2. If we were using exponents with a fraction, you know, and X to the 1/2 is not the same thing as X to the 1st, you see?
Yep, I got it.
Okay, very good. All right, so we're doing okay? So now we're gonna,
Yes.
so say that again? Yes?
Mhm.
Okay, I don't want to be oblivious over here and think we're doing great and you're like, man, she lost me at this and she never stopped. Okay. I'm not gonna do number 11 because we did even worse than that already. You see, this one's just multiplying a term through, yes?
Mhm.
And then this one here, and I had extras in case we needed them. But let's just make sure we know what we're doing. You see this first one on the left. All you do is FOIL and see what happens. This is no worse than what we did on the last one. This one over here, the only reason I want to fiddle with this is really, if you like formulas, a plus b times a minus b, or a minus b times a plus b is a squared minus b squared. You can do it this way, or you can always FOIL. So square root of x times square root of x is square root of x squared. Then you have an outer plus y squared of x. Just be careful of what's under the radical and what's not under the radical. Minus y square root of x, and then negative times positive is negative, and y times y is y squared. And this one here, the x comes out. These two here cancel, because this is like having plus $1 minus $1. And then do you see how they're not both squared? Because that first one started out with a square root. So just be careful on this stuff. Don't just, you know, don't make it x squared minus y squared. This is x minus y squared. Crystal clear?
Mhm.
Okay? Okay. Yell if you're not okay. Just don't get frustrated. I love teaching. I miss this so much, the online on-ground teaching. I can move around and see faces. And it's still not better. This is better than nothing, but I do miss that. This is just messier, you know? And when you do the last, you're gonna have that last one, you have this one times that one, this one times that one in the end there, you know, you're gonna have a square root of 6 squared and the 6 will end up coming out, and then you multiply all that stuff. You can use calculator. This is similar to what I just did, so I'm not gonna do that one. You see, this just looks messier. Do we need to do another? I mean, I'm not against it. One more real quick, or we're over it, or how are we feeling?
I think I'm doing pretty good. Like, I understand everything that we have been doing lately.
Okay. Okay, thank you, Freedom. So you don't
Yeah, I
need
get
me.
it too.
Okay, so I don't have to do more 10-4, or as you do your homework, if you're struggling on any of them, just shoot, use that ask instructor thing, and I will gladly work it for you and send it to you. I'll even make you a video if you want a video. I'm happy to do whatever you need. I just don't want to bore the class if we've, that horse is dead. We've done beat it.
It's just a matter of practicing it.
Yes, and it's just practicing it and then watching the little details.
Mm-hmm.
Okay, so 10-5, let's make sure we know how to do this. Next week we have 6 and 7. 10-7 is imaginary numbers, so bring some humor and some patience, and they're kind of fun. So rationalize the denominator. What does this mean? What is a rational number? And this is when I go back into basic math. What's the definition of a rational number? And a rational number is simply anything that can be expressed as A over B, where B is not 0, meaning you're never allowed to divide by a 0. We've been over this and over this. That's not legal, undefined, whatever. So, a 5 is a rational number, isn't it? Because I can write that as 5 over 1. A 3/4 is a rational number. Anything that can be like a fraction. 3.5 is a rational number because I could write it as 7/2. 0.75 is a rational number because I could write it as a 3/4. Are we clear? Like, that's the whole idea of a rational number. But a square root of 5, let's say, I'm making this up now, or ask your calculator, what's the square root of 6? And your calculator will shoot out some crazy decimal thing, and then I call it that crazy decimal. It's not rational if it's crazy. You can't be rational and irrational at the same time. So anything like square root of 9 is rational because the square root of 9 is 3, and 3 can be written as 3 over 1. But a square root of 6 is just a mess if you ask your calculator, because it's not going to come out clean. So what this is saying is you need to make the denominator a rational number. So then we can argue. I'm going to show you something that's very wrong, but I have to show it. Some people say, well, I hate it when you do that because it confuses me. But let's look at a number. And let's look at a number and say, hey, I have this number 110. 1 over, let's use 1/10. And then I'm going to do this in red now. I'm going to erase everything I'm doing, so do not write this down. But some people say, hey, I can just square that, because wasn't my goal to bring that 6 out? Because then it's rational. And then some people say, well, I'm just going to do that. And that would then bring out that 7 over 6. And this is not true. For the same reason, if I square this and square this, I get a 1 over 100. So you're telling me that 1/10 equals 1 over 100, and that is not true. So you can't just square numerator denominator, okay? That is not something that's legal, so don't try it. But I do bring it up because people do it all the time. They want to do this. Now, what can you do? If I told you you have a 2/3 and I want you to make that into a 9, could you, if I asked you to? If I asked you to change this 3 into that 9, you would say, yes, I can do that because I've done that before, times 3, whatever I do downstairs, I do upstairs. You see what I'm saying? Here, you're essentially multiplying this whole thing times 1, and that is completely legal. So we're going to use that same thought process here. We want that 6 to come out. What do I need to multiply this by? Another square root of 6, because my goal was to create a square root of 6 squared, which is a 6. So I'm going to focus on the denominator right now first, because I'm going to look at my denominator and say, what's my goal? My goal is to get that 6 out from under there. So Whatever you do downstairs though, right? The rule is you have to do the same thing upstairs. And you're not allowed to square, but you can take it times something. Because here, look at this piece. This piece here is like you saying, I'm multiplying everything times 1. You see, so you didn't change anything. Oh, good. Like that's keeping it legal, like mathematically. That's what, but we look at what is our goal in the bottom. We want the radical to be gone. To make that rational, you have to get rid of the radical sign. Okay, maybe I should have been more clear. You cannot have a radical sign as a final answer in the denominator. Yes? So you need to know that's not going to be a final answer. You have to have the denominator rationalized, meaning no radical. So what happened to the numerator then? Square root of 7 times square root of 6. Don't all yell at once. Maybe my internet's bad. Everybody's frozen.
The 42, the square root of 42.
Thank you, Deanna. I see you. Okay, so and then square root of 42, can you simplify it? You know, and if I ask you to square root of 42, it's really 6 times 7. It's really 2 to the first, 3 to the first, and 7 to the first. You see what I'm saying? Nothing's ever going to come out. So it's simply the square root of 42. And this is my final answer. This is exactly the same thing as that if you ask your calculator. So, you know, I really wish you would get used to your calculator and just plug in there, square root of 7 divided by square root of 6. And you look at what that decimal is, it's going to be some crazy decimal. But is that the same crazy decimal as square root of 42 divided by 6? You see, because that's how you can check your work.
Mhm.
How are we doing? Yeah? So get used to use your calculator. This is the one time you can use some decimals just to see if you're on the right track, but the decimal is not going to be, don't try to enter decimals in the MyMathLab. It's not going to fly, okay? Decimals are not going to fly because they're not exact unless it's a 3/4 and it's 0.75 and it ends. A square root of 6 or this thing here, if you put that in your calculator, it'll be some decimal that goes on forever. You can't put that in there. It won't let you. Okay, so let's try another one. Usually the first one's a little weird and then we do a bunch and then everything's crystal clear. So it says rationalize the denominator. So we lost 2 people. As long as everything's crystal clear for them, I'm good. So I'm going to arrow over, or you can arrow down. Usually I would like to work down, but on these short ones, it's kind of nice to arrow from left to right. So that's personal preference. But what can you do? You should probably split them up. I'm going to make it look like this first. You could go ahead and fiddle with the denominator first. So this is personal preference. Are we okay? So that I just simplified this first. And now I'm going to try to get rid of the radical under the line, like in the denominator. So how can I need to get that x out from under. So what do I have to multiply?
By the square root of x.
Right? Because that's my goal. My goal is this. And, you know, that's my goal because that then leads to that radical to disappear. So I have to look at what's going to make that happen. Oh, square root of x. Whatever I do downstairs, I have to do upstairs. Is that helping? Like how we're done? And the nice thing about Zoom, you know, I just saw Amber taking a drink. You can have an alcoholic beverage here at home.
It's a LaCroix. It's a LaCroix.
You know how we sometimes say we need to.
So just to clarify, the x came out from under the radicand because we squared it.
Because my exponent matched my index. So remember from the other day, the cube root of 125, let's say. And we said, hey, the cube root of 5 cubed, 5 times 5 times 5 is 125. If these two are the same, this thing comes out clean and the radical is gone.
Yeah, I guess I just wasn't looking at the screen, I guess, and I was like, whoa,
Okay.
what's going on?
No, it's totally okay. So you want to always focus on what's my goal. My goal is to make this here happen. How does this happen? I need to have an exponent that matches the index. How did I make this happen? By multiplying this piece here, multiplying it by this piece. And then here you have to be careful that you don't change the original, the value of it. And you have, you're essentially multiplying everything by 1. You're not hurting anything. You're not changing the value of the original. So hopefully that helps. Now we'll do another one and that'll hopefully clarify again. Now I'm looking at it. What's everybody drinking?
Wine.
I don't even have any. I had some old wine and I mean, I'll open a bottle and 6 months later, I'm like, oh, there's a bottle of wine open. And I could really use a little during this epidemic. So let's look at this one. Are we holding up okay? It's been an hour. We're okay still. I'm okay. So those of you who had me from 9:30 to 12 o'clock on a Tuesday, Thursday, this is nothing. And you couldn't run away. Right now you can quietly like get out and all I hear is a little
breeze compared to on campus.
Right, time-wise, yeah. So let's look at this piece. Now, I understand some of you, I'm going to do it in red, but I understand some of you are going to say, hey, let me multiply the denominator by this. You know what I'm saying? Because then you'll have a 45 squared and an x squared if you multiply this denominator by that. I'm trying to use the draw feature, you see? I don't like doing this. I have good reason why I don't like doing this. You are correct. You would create a square root of 45 squared x squared. You know what I'm saying? But then the numerator will have to be simplified and the denominator has to be simplified. So I'm not going to do it this way. I'm not saying it's completely wrong. We're going to do the following. We're going to simplify the denominator. Okay, let's do that. Like there's different ways to do stuff. We just need to accept that we sometimes have to make some decisions. 3 squared is 9. 9 times 5 is 45. And then I have an x. Are we okay so far? So everybody's freezing all the time on the screen.
I'm just doing it, yeah.
Okay, so we're good. And then we have a 2 over 3 square root of 5x. You see? If you do it this way, you will keep it manageable because now you're going to say, hey, I need to get something out from under there. I got to make that radical disappear. How about, what should you multiply everything by?
Square root of 5x.
Very good. Yes? I like it. That's good stuff. Square root of 5x. Because that causes 3 square root of 5 squared x squared. And that was my goal. But whatever I do downstairs, right? Are we good? This here has to be 1. Square root of 5x divided by square root of 5x equals 1, meaning I changed nothing on the value of this expression. Upstairs is going to be 2 times the square root of 5x. That's not anything to do with 10, folks. The 2 is outside, okay? Are we clear? Like you have to be careful here. Some people put it under the radical. The 5 comes out. Are we okay that the 5 comes out and the x comes out? And is it okay if I bring the 5 out and go ahead and make that a 15? And then that x turned into an x. I didn't want to rewrite it again. Is this acceptable for you guys?
Yes.
I cut one step, you know. If you did the 45 thing, then you would have to take and simplify upstairs, downstairs, and you would still end up with this as a final answer. You would just have to do more work. Because upstairs, that 3 would come out, and then that would cancel with the downstairs 3. So I would suggest don't do it that way. Just simplify it first, like we did from here to here, and then say, what do I need to do? The smallest thing I need to do to bring that stuff out from under the radical. Okay, so we have 12 people still. I can see all of you. We're still okay? Did anybody chat? Nobody's been telling me about the chat. What do
I haven't seen anything.
Okay, Amanda, we lost Amanda, probably due to some, let me check the chat real quick just in case. 17
Adam's
chats.
gone.
Oh my gosh. Oh, okay.
Yeah.
Yeah, Adam has the same problem I'm having. Thank you, Adam. You can't hear me. This was 10 minutes ago. Okay, that's funny. Right, the examples with money. They make sense. If this is why I like teaching this stuff in person, because I can make it so simple instead of making it so complicated.
Yeah, I would never take an online math class again. I wish I had started out the year in class. It makes a huge difference.
Yeah. But now you're benefiting as far as, you know, we can look at something positive that came out of all of this. You know,
Something good from COVID, I might pass algebra. No joking.
But you're fully understanding it. And, you know, like you feel more confident because you're not just fumbling around and saying, oh, am I right? Or what, you know, you kind of know now. It's nice. Yeah. So what are we doing? How are we doing with this? Let me see what else is there. This is the last one. So let's do that last one. Is that okay?
Mm-hmm.
Okay, so first I'm going to take that and say, let me simplify this. 18 is 9 times 2. You see how kind of like they use a lot of the same numbers. 3 squared is 9 times 2 is 18. So the 3 comes out. I guess this time I decide to work down. I'm not always consistent. You'll have to forgive me. Yes? And then now I want the radical to disappear. What do I need to do? Multiply the denominator by? And you see how it's really, you can keep it really basic, and then whatever you do downstairs, you do upstairs. The denominator turns into 3 times square root of 2 squared or square root of 4, you see? And that then creates 3 times 2, which is a 6. I'm just looking at the denominator. I hope that's okay. It's just easier for me to just focus on the denominator and keep working it. And then my numerator is just square root of 5x times 2. And now this time it is under. You know, if the index matches when you're multiplying, you can go under. So 5x times 2 is 10x. And there's nothing that's going to happen with that. Mm-hmm. This is it. You know, so these aren't bad. If you run into anything weird, send me a question. We can always, you know that you can do homework late. I hate saying that because there's some people that really struggle with procrastination. And then next, you know, but after next week, we have a quiz due. So it's better, you're always better off working your homework early. You can always improve your homework. So you got to have 80% to get the quiz, but you know, between the 80% that you need to reach the quiz, you can still go in there and improve your homework score by the end of the semester up to 90, up to 100%, and then it'll help your overall grade some. Any questions?
No.
I am good.
Okay, so I hope that helped. I think it helped. And then next week we'll do what, 10.6 and 10.7. And then see, then it's almost over because in chapter 11, we only have 2 sections. One is tough. You don't want to miss that one. We'll probably spend an extra day on that one.
Okay.
Yeah. Jordan, all is well?
Yeah, it's all good. I already did all the homework. So I'm just
So this was just really boring. Or good to help you on the quiz and on the test then.
Yeah.
I'm gonna have to hop off here.
Okay.
Yeah. Have a good weekend. I'll see you
I think
Monday.
we're all leaving. Okay, we'll see you later. If you need me, I'll stay on for a few minutes. I'll see you guys later. Thanks for coming.
Thank you.
Thank you.
yeah.
Randy, I see you're still here. If you need to talk to me, feel free. Nobody else is in here now.